Hello Year 1. We're going to be doing a quick starter reminding ourselves about 3D shapes. It's quite a long time since we've covered this. So we won't do all of this PowerPoint, we're going to do a little bit today and a little bit tomorrow. So our 3D shapes, these are shapes that we can pick up. We can use some language to describe them. They have faces that might be flat or they might be curved. Instead of corners, we say vertices. So where lines meet, we get our vertices, and we have edges, which again can be curved or they can be straight. So this shape has got vertices here, 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 and here, and some more at the bottom. Its edges, we're thinking about the lines. And its faces, we're thinking about the flat bits here for this shape. So have a think about if you know the name of this shape. And you would be right if you said a cuboid. So a cuboid has a mixture. It might be all rectangular faces, so rectangles, what we can see here. It might also have some that are square. Didn't mean to press that, but that's okay. So we're going to have a little look at the names of these anyway. So we've got 3 different shapes here. I'd like to think about the names for these. I'll go through them now and see if you were correct. So this shape is a cylinder. You can see these in your house in cupboards, I bet. So any cans of beans, they're cylindrical, they're cylinders. The cylinder has got a curved face here and a flat face at the top, a flat face on the bottom, and those faces are circles. This is a cube. It's different from the cuboid because it has all of its faces are squares. So it's only a cube if all of the faces are square. And then this one is a pyramid. And we can look at the bottom, see what kind of pyramid. Look at its base. It's a square base pyramid. So it has a square on the bottom. Then it will have 1, 2, 3, 4 triangular faces. Cylinder, cube, and a square-based pyramid. If you can just remember that's a pyramid, that's super for now. So the question was to see if you can think which might be the odd one out. So the answer they had on here was a cylinder because it's the only one of these that has a curved surface and curved edges. So it's got 2 edges. But in the live sessions, we'll have a think if anyone's got any different answers as well. So you could think about things like the amount of faces. You could think about how many edges, how many vertices. So let's have a look at this shape. Now you have to imagine some of these vertices. It has 1, 2, 3, 4 at the top. But you can imagine at the bottom as well, it's also going to have 4. So 4 and 4 is 8. So think about again what this shape is called. You're correct if you said a cube. A true or false question. These 2 shapes, our cube and our cuboid, have the same amount of vertices. True or false? It is true. So I tend to think about it as 4 on the top and 4 on the bottom. And for this shape as well, 4 on top and 4 on the bottom. And the last thing I'd like you to think about for this is, can you think of any things in your house that are either cubes or cuboids or anything at school? You could think about a dice for our cube. You could also think about boxes of cereal if you put that up on its end. So boxes of cereal. When we made our Tudor houses, we made those out of boxes of cereal and we made them a cuboid shape as well and added bits of paper to them. And we'll look at some more of those tomorrow. Now what we're going to be doing today, this is revisiting something called a fact family. And this means that we can use 3 numbers and we can put them in different orders using exactly the same numbers to make 4 different calculations, 2 addition and 2 subtraction. So let's have a little look at this together. We're going to start off with some nice easy numbers to get the idea of this. So I've got my 3 and my 4, and they go together to make 7. 3 and 4 is 7. So I'm now going to get those numbers ready to drag into the right place. So we've got our 3 here And we've got, clicked the wrong number then, our 7. We've got our 4. I'm going to keep using those and dragging them into the correct place. So for the first one, I'm going to put in our 3. Our 7 is the total. So we can say that 3 and 4 equals 7. I can also add, so just to remind you about some of the vocabulary about our part-whole diagrams, 7 is the whole, and these are the parts that we're adding together. It doesn't matter which order we add them in. 3 and 4 is 7, and 4 and 3 is 7. So we're using just these 3 digits for each set of questions. And when we're subtracting, we start with the whole, take one of the parts away, and we're left with the other. So if we start with 7, and we take away 4, we are left with 3. So if I make my 7 a little bit bigger, put it here on the screen, we can see that. If I start with 7, and I cross out, I'm going to cross out a big 4 because I can see a big 4 at the bottom. We cross out 4, we're left with 3. But we can also think about it this way. I'm going to get rid of some of those lines. There we go. I've also crossed out the 3. I've started with 7. If I cross out 3, then we're left with 4. So we've only used the same 3 of these digits, but we've made 4 different calculations. We've made 2 addition and 2 subtraction, and we're going to just start another one. Just going to pause. And here we are ready to do another one. So this time I'm going to have a 10 in here and a 4. I'd like you to think, if I've got 9 in here, what must the other part be? I keep getting confused with the colours. I wanted a 10. There we go. So a 10 and a 4. So that's 14. And I have got a 9 here. So I'd like you to think, which is the other part? 14 is the whole. One of the parts is 9. You're correct if you said the other one is 5. So my whole is 14. One of the parts is 9. One of the parts is 5. We just picture that little 1 from the top of the 5 going here, it makes 10. We know that's 14. So again, I'm going to put the numbers at the bottom so we can drag those into the right place. 14 and 5 and 9. So we're going to start again with our additions. Thank you for being patient. There we go. So the biggest number isn't going to go here with our addition. We're going to put it here because the 2 parts will make the whole. 14 is the whole. So we can have 5 and 9, but we can also have 9 and 5. So with addition, these 2 can swap over. We can think about some rules with this. So the whole is going to go here for addition, and this is set after our equal sign, and the parts are what we're adding together. But in subtraction, we start with the whole. So I had 14, I took away 5, and I had 9 left. We can swap these around. I had 14, I took away 9, and I could have 5 left. So with addition, it's either side of the equal sign. We can swap those over and it'd be correct. With subtraction, we start with our whole, and then we can swap the parts over. We take 5, we're left with 9. If we take the 9 away, we're left with 5. And here are some reasoning questions. So we've got here 13. If I was solving this, I might just write the numbers just next to it to make it clear. This is 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I agree, 8 and 5 makes 13. But think about my 5 as a 2, and it's made up of 2 and a 3. It's a bit hard to write on here, there we go. If I give 2 to the 8, it makes 10, and then the extra 3 makes 13. So let's look and see what the mistakes are. Maybe I'll use a green to mark. So I agree, they've added 5 and the 8 make 13. That's correct. Now, if we're making fact families, we're trying to show that the same 3 numbers can be used and swapped around. This can be really useful if you've got some clues to a problem, then you might be able to use them to solve something a bit more tricky where the digits are the other way around, where the numbers have been swapped. This isn't correct because they've put some different numbers in to make 13. We're thinking about 8 and 5 and 13 and how they work together. 13 take away 5 is 8. I agree, they've got the whole here and then the 2 parts. And this one, they haven't used the same numbers. So what we're looking at today is using the same numbers. Whoops, didn't mean to do that. Looking at the same 3 numbers they're shown in the part whole diagram to make 4 different number sentences, 2 addition and 2 subtraction. So let's look at this one and think about what we know. Complete the part whole diagram. They've called these stem sentences. We can also think fact families are 2 addition and 2 subtraction sentences. Here, I can see the whole is going to be 15. Because in subtraction, we put the whole first and then take away the parts in year 1. One of the parts is 9. And that must mean I need to give 1 to the 9 to make it 10, another 5 to be 15, so it'll be 6. And now we can use these. I'm again just going to type them at the bottom because it is quicker to drag them in. Make all of these different sentences. Doesn't like that for some reason. Let me do this. I know why. I'm going to put the 15 in first. So that's the whole. So it's going to go here for the addition. But for the subtraction, we start with the whole and take the parts away. And for the addition, I can have 9 here, or I can have it here. And then for our 6, 6 and 9 is 15. And this one said 15 take away 9, so I'm going to have 15 take away 6 is equal to 9. So let's talk about, oh, there's just one number missing, isn't there? We'd need a 6 here. So let's just talk about what you're going to do. Now you have got a sheet that shows you some part whole diagrams, and in your book there's a date here and a title, and you're going to use your part whole diagram to write out, just like this, 4 number sentences. It's very hard for me to get one number per square. I'd like you to try though, please. And then you can set out your work. I'd have room on this for another fact family to go here, and I could line them all up so it's nice and neat in my book. So that's your main activity. And you need to check they're correct and be starting to look at how these numbers can go into different places in the calculation but still be correct. And you also need to check your work for any mistakes. And I have been busy thinking of some good problems for you to solve today. So I thought right back to when we had our tests in the autumn term, this question confused lots of people, but I'm hoping you can do it now. So you had to think about filling in this part whole diagram and using just these numbers to fill this in. So that was the question that most people found hard. So have a little look and see if you can do that now. This one, we're thinking about a sentence, kind of number story that we can fill the different numbers into. I had so many seeds, I planted 14 of them and gave so many to my friend. Can you use the numbers in the part whole diagram to tell that story? So that's to help with your problem solving. And this is just quite similar to one of the ones that we did together. So can you spot any mistakes that were made? And here, now this one is a little bit more challenging, so I'll explain this on the feedback video, but have a go first. I have written numbers on the back of each of these and you can't see them. They've each got a different number. So I've swapped these around so they're in different orders. So using what you know about the rules of making fact families, either this one is correct or this one is correct. So you need to have a look and see what you think. And a handy hint, if you're not sure, maybe just make up some numbers that could be on the back of these, and then test which of these works and which of them doesn't.